need to talk about the shortcomings of arrays as well. And I need to talk about computer memory a bit. So here's the mental model I want you to have of a computer's like RAM, of its memory. So let's say we wanted to store your grade for Wikipedia, right? In this representation of a computer's memory. So that might look like something like this in code, let grade equals 90. But then the model we can think about is the JavaScript engine will look for a free piece of memory, so billions of these empty boxes, and maybe it finds one here, right? And then it stores the value of 90. Okay? So that's not too hard to visualize or think about. But sometimes we want to store not just one thing, right? But a collection of things. So I need to store your grades for all our projects. So Wikipedia, you got a 90. Spammer, you got an 80. Reddit, you forgot to submit the link. You got a 0. Hungry Pets, you got 100. Right? So how do we store a collection of things? Well, one thing we can do is use an array. So for an array, it's still a pretty simple idea, right? The computer looks for, in this case, 4 contiguous memory, empty memory spots, and assigns the values in here. So we can do 80, 0, and 100. So this is the mental model for an array and the memory allocation. And there's some awesome things about arrays, right? So what is great about this? Pros, and then we'll put cons. So, can anyone see any pros of array as a data structure? And if you can use the language of Big O to me, that's kind of what I'm looking for.
Quick lookup.
Yeah. So O1 lookups. And what do you mean by lookups?
Like you can I guess we have to provide like the position or the specific spot in memory, and then we can just instantly get the value at that location.
Yeah, so here we can do grades too, and it doesn't have to go to 90, 80, then 0. It goes directly to the index.
Mm-hmm.
So that's why, can I underline this?
Yeah.
Where's
Does
underline?
have to iterate.
The edit? That one? No. Whatever. It's not that important. Okay, so that's one pro. That's awesome. When we access items in the array, the lookup is like instantaneous, no time at all. In the language of Big O, it's O1. Any other pros? How about simple? I know that's not the language of Big O, but it's very simple, right? Can anyone think of any other pros for arrays? Okay. So what's the cons, right? There's one massive con. And what's that massive con that we want to focus on?
Is it hard to insert data?
Yeah, but speak to me in the language of Big O.
So if you try to insert data, halfway through the array, you have to move every single index over.
Let's not do halfway. Let's just say adding it any which way. So insertions are for any insertion for a very like static array is what Big O. And then we'll get into why.
N.
Yeah, there we go. Really, oh man, linear.
But
why right. Can't so your new grade on Capstone was 100. Why can't I just expand this array and put the 100? Why can't I do that? Whoops.
Well, I think inserting to the end is okay. So we just want to just push to the end. But if we want to kind of go anywhere else, we're going to have to move like every single item over like one spot. And especially if you want to insert it in the front, that's like the worst, because then you're going to have to move every single item after that initial first item that you want to insert in spot one. You have to move it over till the end of the array, which could be n steps.
Yeah. So here's the thing. Our computer, when it made this array, the JavaScript engine just found these 4 empty spaces of memory. But it has no idea. Can I draw some? It has no idea. Where'd that mesh background go? That's what I wanted. Anyway. No. Where's the mesh background? Oh, that's good enough, I guess. It has no idea what's going on with this memory, right? This memory could be Baldur's Gate like 3 or anything. It could be Microsoft Word. So if we try to just add the 100 to the array, we can't, because this memory might be already taken up. So what do you think like if you were in JavaScript, this is all kind of moot because arrays aren't really arrays. They're like objects with combinations of linked list and hash tables, and there's a lot going on, which we'll explore later on, hopefully. But in a static version of an array, the simple version, what do you think it does if it runs into this situation? It wants to add the 100, but it can't. What's one solution it might do?
Moving it?
Yeah, so it creates a new array anywhere it can and looks for 5 spaces, because that's how many it needs. Yeah. And now it can copy this one and put the second, 100. Can I get this lined up? Yeah. Can we switch this color? Yeah. It had to find a new place in memory, which isn't a big deal at all. But the big deal is it had to recreate every number in this array, copy it, paste it, and then add the new value. That's why it's linear time for insertion. Because the input size, as it increases, it has way more steps to do. Or not way more steps, but it increases at a constant rate as you add more items to the array. Questions on that? Okay, so how do linked lists save us in this situation? How does a linked list save us in this situation? Well, what a linked list does, if you want a collection of things, it can store the first, find a free space in memory wherever, store that value. That's fine, right? But then when it wants to store the 80, it doesn't go right next door. I mean, it might, but it might not as well. It just looks for any free space in memory. Because remember, all these boxes could possibly be taken up. And so it finds here and it goes 80, right? And then what it'll do when it wants to add a 0? The same thing. Just finds another free spot in memory. And this time we got lucky. And it was, maybe it was right next door. Well, that might be confusing looking for the diagram. But anyway, it goes maybe here or here. And this one was the 0. And then it has to add the 100, and it found a free spot right there. The point is it can find free spots anywhere it wants. But then the question is, well, how are these, we're going to call them nodes, how are they connected to each other? And the first part of this node, the value is 90, but the second part we call a pointer, and that's going to point to the address of where the second node is stored. And then likewise, no, there we go. And then likewise, this second node is going to point to where the third node is in memory. There we go. And this fourth one has an easy job of pointing right there. So this is how a linked list manages the nodes in its collection. Finds a free spot anywhere, has the value itself. In this case, we're saving grades, but this could be strings or Booleans or anything. But we're just using numbers because it's simple that represent grades. The first value in the node is the grade. The second value is just where is the second node. So now we have a new grade of 65 to add. How do you think we would add a new grade of 65? Well, we've already seen that, right? A bunch of times with 80, 0, 100. So let's skip right to what are the cons? Well, let's start with what are the pros, right? Because there's an obvious one that we should see. So hopefully me diagramming this out prompted you to realize what the pro is, the major pro of the linked list. And what is that, Victor?
It doesn't create more incomplete copies of itself.
Yeah, but speak to me in the language of Big O. What is the Big O for insertion? So adding something new. So it doesn't have to, it really has no bearing how many previous nodes there are. It can just easily add itself. So it's going to be constant time. And really the way we're going to do this today, say let's show this. So we want to add 60 or 60. So what it's going to do is this node is a special node. It's going to be called the head. And when we have a new node, what we're going to do is find a free spot in memory and then add the value. And then this new value will then point to the old head. Can I do this? Yeah. So now this value will really be the new head. So a linked list will always have a head. So there could be a million things in this linked list, nodes, and it doesn't matter because all we need to know is the head, and then we put the node before the head. So we have constant insertion. What is the major con, though? We have a major con.
Is it slow lookup?
Yeah, so lookups are big O of what?
ON?
Yeah, unfortunately. So we lost the awesomeness of arrays where it's instant lookups. Because now all we keep track of is the head for our linked list. So we start at the head and we say, is that value, say we're looking for the value, say for some reason I'm like, well, did this student have a score of 70 in the entire course? And I want to look through all your grades. I look at this first one. I don't. Actually, this isn't a great example because you would have to do the same with an array. So that's not a great example. Yeah, that's not a great example. Because we have to look at every value anyway. Okay, so the array, the awesome part is not that we know exactly where a value is in accordance to the index. The awesome thing with arrays is that if we have the index, we immediately can look up the value. But here, even if I knew, let's say I somehow knew that index, even though it doesn't make sense to use this language with linked list, but let's say index 3, I knew it was a 0. There's still no instant way for me to go to index 3 in a linked list. That doesn't make any sense. We have to start always at the head and then just go to the next node and go to the next node and go to the next node. So lookups are big O of n. That's the big con. Really what happens is in our higher level languages like Python and JavaScript, all these data structures are just combined into these kind of monsters of multiple moving data structures. And then for our developer experience, it's just beautiful. Like we never have to, how many times have you pushed to an array? You haven't created a new one to do that, right? All that stuff is just handled for you behind the scenes. But fundamentally, if you were like building, I actually don't know what layer this would be. This wouldn't be, I don't know if this would be operating system layer or programming language layer, but whatever lower layer this is, definitely not web development, unless again you're using C. You would have to worry about this, right? And think about this. And for our purposes of thinking about it, even though we're spoiled as web developers, mostly, it's potential fodder for interview questions. And it's just super interesting, in my opinion. This is like the fundamental of computer science. How this stuff is actually happening. Okay, so we're going to build this out, this linked list. But any questions on this? And for when we're building this out, I'm just going to make this shorter. So I'm going to simplify things a bit.
Hey Max, I've got a question. Does insertion to a linked list always happen at the head, or
No.
did it happen in the body someplace?
Yeah, it can happen at the head, body, or tail. But the most normal is called prepending, and that's going to be the head. But hopefully we'll do both right now, prepend and append. Okay, let's put that to the side-ish. And the reason we learned classes is because we're going to build linked list using classes. All the data structures we build are going to be using classes. So that's why we went ahead and learned it before, right? So what I would first want to do is represent a node using a class. So I'm going to say class node, and I'm going to have a constructor. And then I want to ask you guys, what are like the two properties that make up a node? What are the two things that I have to keep track of just in a single node?
Value and where the next points to.
Yes, exactly. So value and next is really all I need. That's all a node kind of is. Whoops. So let's do that, right? To create a node, we need value and next, which is next is kind of confusing right now because it's like, well, next is just like a pointer to the next node. And I'll say this dot value equals value. And I'll say this dot next equals next. And that's all a node is, right? But how do we create a node now? So let's create, this might be weird, but let's actually create, I guess it doesn't matter. Let's create 60 and call it node. So how can I instantiate the node 60? Don't worry about the next yet. How can we just get a node with that value of 60 instantiated using this new class? Kimberly, any guess? Although this is pretty tricky.
No, not really.
Okay. Ryan?
Yes. New nodes, and in parentheses 60 null.
Yeah. And we can omit the null. It'll just be undefined, which for our purposes is fine. And then let's console.log this node. And then Ryan, what is it going to look like if you had to guess? Before I press save.
It's gonna be an object with value and next.
Yeah, and what is the value of value going to be?
The value will be 60 and next will be undefined.
Yeah, beautiful. And there we go. So it even told us what class it was generated from, but it is an object with value 60 and next undefined. And that's all we need to build the node. So let's build this 90. And I don't need to ask you guys. I'm just going to do no node 90. I'll call this node 2, I guess. But now the problem, and that's fine. That works. We can console.log that. And we have these nodes. But what's the problem? We don't have a linked list. We just have floating nodes in memory that have no connection. So we need another class called linked list. And really all it's responsible for is pointing at keeping track of where's the head. And initially it's going to be null. But that's all I care about right now for this linked list class. And then how can I instantiate a new linked list object based on this class, David?
You can just do const linked list equals new linked list.
Yep. And it doesn't have a constructor. It doesn't need anything. And if I console.log this, David, what will we see?
I think you'll just see a head that says null.
Talk to me about data type first.
Oh, it's an object
With a property of
head.
And the value is
null.
Beautiful. Yeah. So, yeah. Object head is null. It's so weird, right? It's so minimal. But now we want to add something to our linked list. So we were talking about before, we have those two options. Well, actually right now it's easier than this. So I'm going to add a method called prepend. But basically this is just inserting a node into this linked list, which we need to do, right? Because we need this linked list to have at least a head. So I'm going to add a method called prepend, and prepend takes in a node. And I'm going to say if there's not a head, in other words, if not this dot head. So if this dot head is equal to null, what do we want our new head to be? If we're feeding in this node to prepend.
Node.
Yeah, so we're going to say this dot head just equals the node because it's totally empty, so we got to start somewhere. And now, how can we make it so that I'm actually going to do node 3 equals new node of 80. I actually want to first add node 3 to my linked list. So how can I add node 3 to my linked list? Hara, do you have a guess?
No, I'm not sure. Sorry.
Okay. Ketzer?
Not sure to. Sorry.
Okay. Open to the class.
You can do linked list prepend.
LL, I called it. Should we
prepend.
change that? Is that confusing? We'll do little linked list. Yeah. Okay, so linked list dot
prepend. And then pass in, what'd you say, node 3?
yeah. But as I'm looking at, and then what will we see in the, describe the console.log of linked list, David, when I press save. This is starting to get a little more interesting.
So I think it'll be an object that has the node.
Not yet. So it is an object, but what property does it have?
It's got head, and the head will be the node 3.
Yeah. So the head will point to node 3, which itself is what?
An object
With the
that has
properties
value,
of
value and next.
Yeah. So let's see if David got all that. So I have an error. Oh, I just have a spelling mistake. Okay, so he said it'd be an object, check, with a property of head that points to a node. Yep. And that node has the properties of next, undefined, and value 80. Awesome. But I'm also seeing an improvement I can do to this. I don't want to manually write out my nodes like this, I would rather just pass in the value 80 and have prepend just make me a node. So I'd call this like value. And then how can I change this logic to just like make me a node with that value? Make me a node with the value. That's cleaner, right? To just pass in the value when we want to, and it will do the work of making the node. How can we do that?
Can you do like new node.next or something like that?
Very close. New node to make a new node object. And what value does it need?
Value.
Value. Yep. And whatever value we're passing in. And well, what we could do here is this. There's nothing wrong with that, I guess. Is that easier to read than saving it first? Maybe. So now this is very nice. We just say prepend 80 and it makes the node for us. But here's where things get even more interesting. On our diagram, let's add the 90, and the 90 is going to point to the 80. So in this case, if we prepend, right now, if we prepend 90, what actually will happen? What will we see in our console? Renata, you have a guess? Or, yeah, go ahead. Somebody start talking?
You shouldn't see anything, right?
Well, we're console.logging linked list.
You'll see the old value, right?
Yeah, but what's the old value?
The 80.
Yeah. So data type object, property head that points to the node. Yep. And this line basically did nothing because there's nothing. The head exists. So we need an else here. So now, what do we want to do? How can we want the new node. We want to create a new node. We want to point the new node at the old head. We want to set the new node as the head. And I'm actually seeing a little optimization we can do. I believe. So we don't have to create a new node. Already done for us with the little optimization I did that I think will work. How do I point this new node at the old head? So we're trying to do the 90 and the 80, create that connection.
Just
So
do.
are we?
Yeah. I think Ronald was
node.
first. Go ahead.
Oh, sorry.
No, I think you were
I guess
first. Go ahead. Yeah.
Okay, sure. If node is that variable is a new node, then we want to point it to the old head. So node dot next, we want to set its next pointer to point to the old node or the head. So this dot head.
Beautiful.
Right.
And then how do we make the new node the current head?
So we would say this represents linked list class. So then this dot head should be equal to node.
Yeah. Awesome. Yes. Yeah. Okay. So let's test this, right? So we basically want to see this 80 and the 90. That's what we're trying to see. So what we're hoping to see is that the linked list is an object with a head that points to a node that's an object with the value 90, and its next points to a node with the value of 80. That's what we tried to build. So let's see if we were successful. So we have a linked list with a head that's a node, and that value is 90. Great. And its next is a node, and the value is 80. So we've successfully built these two items in the linked list. And then how can we get the 60? Renata?
I don't know.
All right, Victor, any ideas? How can we prepend this new node of 60? It's going to be very similar to 28 and 29.
Just add linked list prepend 60.
Yep. And now, what is the head going to be when we console.log it? What value is the head node going to have of our linked list, Victor? If it goes well, it's going to be this exact representation.
It should be 60.
Yeah, so 60 starts the party. It's the master node, the head node. So did we do this right? Yeah, value 60.
So any recently added prepend will be the new head, unless dictated by the code.
Yeah, I mean, it's going to follow this logic. So we're always adding to the head, and that's why we called it prepend. So, like David said, what if we want to add to the tail for whatever reason? How can we go ahead and work on that? So let's call this append. Let's assume that it as well is going to take in a value, and it has to create a new node. And if there's no head, well, that's easy. There's only one items in our linked list. So we know what to do there if there's no head. But the hard situation is if there in our linked list, there's already 3 items. So we have this currently. So what we want to now do is add is add 100 for the capstone grade. To the tail. So this is the head and this is the tail. So we want to add this to the tail. That's what we're trying to do, to add this 100. So how can we, append. So append means we're adding it to the end. Yeah. So any ideas, this is trickier, but any ideas, how can we need to find the tail. Point from the tail to the new node. Those are kind of our steps. So first off, how do we find the tail?
You can check for null as the node's next property.
Yeah, so we got to start our search at the head. and just keep going till we know the next property of the final node is null. So we can say like let current equals this dot head, and then while current dot next exists, we want to change current to be current dot next. So if I console.log current now with our current, I'm going to say linked list dot append 100. What will I see for my value of current? I'm setting current initially to be this dot head. It'll be 60. And then I'm saying while there's a next that's not null, just move current to be the current next. So what do I think? When I console.log this, which node will I see?
The last node,
Which is?
100.
No, 100 is what we're trying to add. Sorry.
80.
Yeah. 100 is, we haven't added it yet. See, we're trying to add it right now. So, yeah, we'll see the 80 node. Yep. And now that was the hard work. Now, what do we have to do to make this connection right here? So current is a node with property value of 80 and next is undefined. What do we want next to point to?
A new node.
Yeah. So how do we get the value of next or the property of next to point to the node?
The current dot next is equal to node.
Yeah, beautiful. Yep. So now let's test this by console.logging linked list. Jiang escaped today. She had a mock, her mock technical. Oh, there she is. Okay, awesome. Because I have a good one planned for you today involving linked lists. I'm glad you're here. You're hiding at the bottom of my screen. Okay, when we console.log linked list, let's see if this worked, right? So what we hope to see is... What do we hope to see? Oh, yeah, we hope to see this, right? Because we prepended these, but we appended the 100. So we want to see 60, 90, 80, 100, I believe. 60, 90, 80, 100. I think we're good. No. Wait. So our head node has a value of, no. Our head node has a value of 60, correct. The next value has a value of 90, correct. The next value, I don't know. This gets hard to read in the console. I think it's right. I think we successfully did this. But a hint for Jiang, her mock technical is going to be helping us visualize what's going on. That's a big hint. Okay, this stuff is obviously very hard. We've barely used classes, and now we're doing this weird linked list stuff. What else should we do? What else? Well, maybe we should call it right there, right? That's kind of heavy lecture. So the mock technical, try to build out everything we built here. There are so much more methods you can do with linked lists. So think of different things you could do with linked lists. So Shout outs. Who else? Who can think of some other things you could do to a linked list that we haven't done?
Make a circle.
No, then it wouldn't be a linked list.
Find something or like
Delete
Find. Yeah, search. What else?
Delete.
Delete. Yeah, great one. What else?
Update something.
Date something?
No, update something, like maybe change an item.
Yeah. Yeah, we could do that. Anything else? That's a good start. Yeah. So definitely practice making these linked lists and try to challenge yourself to do these other methods. Jiang is going to have to build a method, but it's not one of these, unfortunately. But it should be a fun one. Okay. Any questions on that?
Yeah, I have a question. Like, I guess it doesn't really matter too much if it's null or undefined, right? For next, but traditionally, next is supposed to be null, right?
Yeah, traditionally. Yep. So
So can we add like a default parameter on the
yeah.
constructor for next?
Yeah, it would be cleaner, I guess, to do this. Yep.
Yeah.
Yeah.
And then I have just like if I technically just, I mean, not creating these class methods, but if I just wanted to connect like 3 nodes together, I can just do like new node 80 and then put in the second argument a new node 70 and then put that in another argument and put like new node 60 and then
Yeah.
all three.
Yeah, that's clever. Yeah. So what he's talking about is new node 70 comma new node 55 comma new node 100, right?
Yeah, and then save it.
And then console.log. And then we'll delete this one. Yeah, that should work. It's kind of ugly, but it works. Yep. Interesting. Other questions? All right. Breakout rooms.